This video is finding a side length using trigonometry. Alright, first up we have the steps. These are what to do in order that you need to do it. Here's the steps of finding a side length. In the next video you'll see that it's actually the same order of steps for finding angles as well, but let's work on this first. First thing, the step is label the sides. Every triangle in trigonometry will have an opposite side, an adjacent side, and the hypotenuse. Remembering that hypotenuse is the longest side, always opposite the right angle. Opposite is the side that is opposite the angle that we're working with, and adjacent is the one next to or adjacent to the angle that we're working with. So once we've labelled the sides, we need to look at which two sides that we'll be working with. There'll be one side that we know, and there'll always be one side that we are trying to find. So those are the two sides we want, two of these three. Once we know the two sides, we need to select which ratio we're using. Are we using sine, because we have opposite and hypotenuse? Are we using cos, because we have adjacent and hypotenuse? Or are we using tan, because we have opposite and adjacent? So when we've labelled the sides, pick which ones we're working with, then we pick which ratio, sine, cos or tan. Then we write our ratios rule down. So we'll have an equation for it. Once we have written out the rule, the next step is take the bits of information that we're given, the angle, the side we have, the variable for the side we want, and we substitute those into our rule. Then we need to rearrange that rule, so the unknown is the subject. We need to get it by itself. And at that point we have something we can then put into a calculator. Remembering, of course, before we do that, our calculator has to be in degrees mode. Your calculator somewhere should say DEG, or sometimes it might just be a D somewhere. If it's not in degrees, your answer will be wildly wrong. So you need to make sure it's in degrees mode. That means that the calculator assumes every number you put in there is a degrees. Very important. Alright, let's look at to go through these steps. Right, we have here a triangle. We have an angle that we're dealing with. We have one side we're given and one side that we're trying to find. Alright, so first steps was label the sides. So if this is our right angle here, then opposite that is our hypotenuse. So we'll label that with a H, clearly the longest side. Here is our angle. Opposite that we have the opposite side, and the side that's touching our angle that's right next to it is the adjacent. Beautiful. Sides labelled. So which two have we got? Well, there's a number next to our H, so we're dealing with, so we've got the hypotenuse, good to know, and there's a letter, an unknown, next to our A. So we've also got the adjacent. Now if we remember back to our SOHCAHTOA, SOHCAHTOA. We're looking for the one that has A and H next to each other there. So we're going to use the Ka, which is cos. Alright, so we've labelled sides, identified the ones we've got, and we've picked a ratio. The next step is write out the rule to our ratio. So the rule for cosine is the cosine of our angle equals the adjacent divided by the hypotenuse. That's our rule for cos. So that's what I mean by the rule for a ratio. Right, next step was substituting the values that we have. So we have the hypotenuse, we have the angle, and we have a variable for our adjacent. So we can sub them into our rule. So we rewrite it out again, saying that the cosine of now 15 degrees equals our adjacent side, which is x, divided by our hypotenuse, which is 30. Alright, now that we have an equation with numbers that we can work with, we want something that says x equals something, so that we can put that into a calculator. So the next step is rearranging. So to rearrange this, we've got cos 15 equals x on 30. We need to get rid of this 30 on this side, so we're going to times this by 30 because it's divided by 30, and then we do the same thing to both sides always. So we're going to times this side by 30 as well. Now we've got a times 30 and a divided by 30 on the same side, so they can cancel out nicely, leaving with just x on that side. There's nothing to cancel on this side, so that stays the same. So now we have 30 times by cos 15 equals x. So now we've got x as the subject on this side, so everything's on this side. We can put that into a calculator, remembering of course our calculator has to be in degrees mode, and that will give an answer of x is equal to 28.98 meters. Quick check of the logic. If this is our hypotenuse, the longest side, our side x here, the adjacent side, has to be less than 30, otherwise it doesn't make sense. And it is. Beautiful. So, let's look at another example. Another triangle here. Got two sides that we know. One side that we know, sorry, and one side that we don't. Trying to find it out. So, first step again, label the sides. So, here is our right angle. It must be a right angle triangle. There's no right angle. We can't deal with it. So opposite the right angle we have the hypotenuse, the longest one. Here's our angle of interest over here. Swing. And opposite that we have the opposite side. Next to that we have the adjacent side. Sweet. Sides labeled. Next up is which two ones are we dealing with? So we have an 8 meters here next to an O, so we're dealing with the opposite. We also have an E, a variable, next to a H, so we're dealing with hypotenuse. If we can remember back to SOHCAHTOA, our little guide for the ratios, we're looking for an O and a H. O and a H is in the first part, so we're dealing with sine. So, first step is, what's the rule for sine? What's the rule for our sine ratio? The rule for our sine is sine of an angle theta is equal to the opposite side divided by the hypotenuse side. So, we have our rule, beautiful. We have a ratio selected, a rule for our ratio. Next thing we want to do, take these numbers and letters that we have over here and chuck them into this. So we have an equation to work with. So let's substitute in. We now have sine of our angle, which is 50 degrees this time. 50 degrees equals the opposite side, our 8 meters, divided by our hypotenuse, which this time is our variable E. Alright, this one, this equation here, you may notice is a little bit different. It looks very much the same, but there's one important difference to the last time. This time, our variable E is underneath here, which means we've actually got more work to do. There's just one extra step that makes it a little bit more annoying. So to rearrange it, we want to get this E by itself on one side and all the rest of this on the other side to give us something to chuck into a calculator. So the first step is if we've got something divided, sine 50 equals 8 divided by E. Now we've got to divide it by E, so we're going to times by E, divide and time being the opposite of each other, and always doing the same to both sides. Otherwise our equation becomes unbalanced. We don't like that. We're going to divide it by e and a times by e, so we're going to cancel them out. Beautiful. This is looking better and better. Nothing over this side to cancel out, so we've got e times sine of 50 equals 8. That's the steps we took last time, but this time that leaves us with our e still with stuff next to it, so we can't have that. So we've got another step to do. Our next step with our e times sine of 50 equals 8 is to get rid of the sine of 50 that's on this side. We do that by, if this is times by sine 50, we need to divide by sine of 50. And again, obviously, do the same to both sides. So we're going to divide this side by sine 50. Now, as we've got a sine 50 divided by sine 50, these two then can cancel out, which is kind of what we're aiming for. Over this side, however, nothing we can cancel out over here, so it leaves us with e equals 8 divided by sine of 50. Now this is what we're looking for, because we've got e by itself over this side. A variable alone is the aim of what we're going for. So then we can, making sure our calculator is in degrees mode, always in degrees, otherwise incorrect answers, we can put this side of the equation in a calculator. When you're chucking it in, you can use the fraction, or you might want to put it in something that looks more like 8 divided by sine of 50. Either way should work, and that will give you an answer of 10.44 meters, which is our units. And that is our answer. Again, we can use a bit of a logic check here. We were looking for the hypotenuse, our longest side, and the shorter side we were given is 8 meters, so this has to be longer than 8 obviously, and 10.4 longer than 8. Beautiful. We're done. Alright, so they're the two types of questions you can get for finding a side length. You can find one of the shorter sides, which will be on top of your fraction, or you can find the hypotenuse, or in case of using tan, finding the adjacent, and that'll be the underside of your fraction. And there's the two different ways to work it out. The idea of this video is, no matter whether you have sine theta, is ONH, whether you're using cos theta equals A on H, or whether you've got a question that uses tan theta equals O on A, you use the same steps to work it out. You, as I said earlier, identify the sides, go through all the following steps. So if you're struggling with a question, what you can do is work out which ratio you need to use, sine, cos, or tan. Chuck in what you got. You can look at whether you're trying to find the top part of the fraction or the bottom part of the fraction. Go to that question and follow the steps. It'll show you how to work it out. Your numbers will be different. Your sine and cos may be different. You may be trying to find the bottom one, but this time you're using cos, whereas in the video I've used sine. That doesn't matter. If sine, cos, and tan will be different, and your numbers will be different, the steps will be the same. So you can substitute your numbers and follow the steps. That'll go through any finding the side length question you've got. Done. Done. As I did say, the last step in each one is always celebrate. Yeah.